Last night, your body may have burned almost no fat at all while you were sleeping. Not because you ate too much, not because your genetics are bad, and not because your metabolism is slow or broken. In fact, the real reason might be something much simpler. In the few hours before you went to bed, and during the night itself, a few small factors quietly change the way your body operates while you sleep. Instead of switching into a state of repair and fat burning, your body may have shifted into a mode that favors energy storage. And the surprising part is that most people never realize this is happening. 3 everyday things play a major role in this process: the temperature of your bedroom, the timing of your last meal, and the light your eyes are exposed to before sleep. These may seem like small details, but together they influence some of the most powerful hormones in your body: melatonin, cortisol, insulin, and growth hormone. Throughout the night, these hormones work together like a control system, and depending on the signals they receive, your body makes a decision. Will it burn stored fat for energy, or will it keep that fat locked away? Most people sleep in a bedroom that feels comfortable, usually somewhere between 20 and 24 degrees Celsius. And on the surface, that sounds perfectly reasonable. Comfort should help you sleep better, right? But biologically, comfort is not always what your body is looking for. To enter deep sleep, your body actually needs to cool down. Your core temperature has to drop slightly, usually by about 1 to 1.5 degrees Celsius. That small drop is not accidental, it is a signal. When your brain detects this change, it begins releasing melatonin. Melatonin does more than make you feel sleepy. It tells your body that nighttime repair has begun. This is the moment when your metabolism starts shifting into a different mode. Cells begin repairing damage. Tissues regenerate. Energy systems reorganize, but when your bedroom is too warm, that transition becomes harder. Instead of smoothly lowering its temperature, your body has to work to release heat. It sweats more. Blood flow changes, and the nervous system stays slightly more active. All of that requires energy and attention from your body. And when your body is busy regulating temperature, other important processes become less of a priority. Processes like cellular repair, metabolic optimization, and the gradual use of stored energy during sleep. In other words, instead of focusing on recovery, your body spends the night trying to cool itself down. And this is only the beginning of the chain reaction that can shape what your metabolism does while you sleep. A few years ago, researchers ran a fascinating experiment that revealed just how sensitive our metabolism is to the environment we sleep in. In a study published in 2014, healthy adults slept for several weeks in carefully controlled bedroom temperatures. One group slept in a room around 19 degrees Celsius. Another group slept in a warmer room closer to 24 degrees. Nothing else about their lifestyle changed, but inside their bodies, something remarkable happened. The people sleeping in the cooler environment showed a significant increase in the activity of something called brown fat. Brown fat is very different from the type of fat most people think about. What we usually call body fat is white fat. Its main job is to store excess energy. Brown fat works in almost the opposite way. Instead of storing energy, it burns energy to generate heat. This special tissue is packed with mitochondria, tiny structures inside cells that act like microscopic power plants. These mitochondria use both glucose and fatty acids as fuel, converting them directly into heat. In simple terms, brown fat behaves like a natural calorie-burning furnace inside your body. Even more interesting, repeated exposure to cooler environments may gradually encourage some white fat cells to behave more like brown fat. Which means sleeping in a cooler room does not just affect one night of metabolism. Over time, it may slowly reshape how your body handles energy. But temperature does not just affect comfort. It also shapes the hormonal environment of your entire night. In a healthy sleep cycle, one hormone in particular follows a very specific rhythm: cortisol. Most people think of cortisol as a stress hormone, but it also plays a major role in regulating blood sugar and energy availability. During an ideal night of sleep, cortisol gradually falls and reaches its lowest point sometime between midnight and around 2 in the morning. This window is one of the deepest recovery phases your body experiences. Cells repair damage, tissues rebuild, and the body begins shifting toward using stored energy. But when the sleeping environment is too warm, sleep often becomes lighter and more fragmented. Small awakenings happen more frequently, even if you do not remember them. When that happens, cortisol does not drop as low as it should. And this is where the metabolic chain reaction begins. Higher nighttime cortisol signals the body to keep more glucose circulating in the bloodstream. To manage that glucose, the body releases more insulin. Insulin's primary role is to store energy, not release it. So when insulin remains active, the process that unlocks stored fat for energy becomes significantly suppressed. In other words, a warm sleeping environment can quietly trigger a hormonal pattern that keeps your fat reserves locked away while you sleep. Now let's move to the second habit. And for many people, this one may have the biggest impact. Late eating. A late dinner. A snack at 9. Something small just before bed. It feels harmless. But metabolically, it can reshape the entire night. Every time you eat, your pancreas releases insulin. Insulin's job is to move glucose out of the bloodstream and into cells where it can be used or stored. The important detail is that insulin does not disappear the moment you finish eating. After a moderate meal, insulin may take 3 to 5 hours to return close to its baseline level. If the meal is high in carbohydrates, that window can stretch even longer, sometimes 6 to 8 hours. So imagine this simple timeline. You eat dinner at 9 in the evening. You go to bed at 11. For the first part of the night, your body is still processing that meal. Insulin remains elevated. And while insulin is present, the enzyme responsible for unlocking stored fat becomes strongly suppressed. This means your body will prefer to keep using glucose that is still circulating in your blood. So even though you are asleep, your metabolism has not fully shifted into nighttime fat-burning mode. Your body is resting, but it is not yet tapping into its deeper energy reserves. There is another important piece of this nighttime puzzle, and it happens during the first few hours after you fall asleep. This is when your body releases one of its most powerful repair signals. Growth hormone. In childhood, growth hormone is responsible for physical development. But in adults, its role shifts toward maintenance and recovery. It helps repair tissues, supports cellular regeneration. And importantly, it helps trigger the release of fatty acids from stored body fat. In other words, growth hormone encourages the body to tap into its deeper energy reserves during sleep. But there is a catch. Growth hormone and insulin work in opposite directions. When insulin levels are high, the effectiveness of growth hormone drops. So if your insulin is still elevated from a late meal, the natural nighttime surge of growth hormone cannot fully do its job. At the same time, your body's ability to process carbohydrates changes throughout the day. During the morning and early afternoon, your cells are generally more sensitive to insulin. They handle glucose more efficiently. As evening approaches, that sensitivity gradually decreases, which means the same meal that your body handles easily at noon can create a much stronger metabolic response late at night. That is why many sleep and metabolism researchers suggest finishing your final meal at least 3 to 4 hours before bedtime. There is one more factor that quietly shapes what your metabolism does at night, and it has nothing to do with food or temperature. It is light. More specifically, the artificial light we surround ourselves with every evening. Your body runs on an internal timing system known as the circadian rhythm, a roughly 24-hour biological clock that coordinates countless processes inside your body. This clock helps determine when hormones rise and fall, when your body prefers to burn glucose, and when it begins shifting toward recovery and energy repair during sleep. But this system relies on one critical signal: light and darkness. Inside your eyes are special cells that respond strongly to blue wavelength light, the type of light commonly emitted by phones, tablets, computers, and modern LED lighting. When these cells detect blue light in the evening, they send a message to the brain that it is still daytime. And when the brain receives that message, it delays the release of melatonin. As a result, the timing of sleep begins to drift later, but the effect goes deeper than simply falling asleep later. The entire hormonal rhythm of the night shifts with it. If you still wake up at the same time in the morning, the window when your body naturally burns stored fat during sleep becomes shorter. When these three factors begin to work together, something interesting happens. Your nights start to look very different metabolically. Not because you changed your diet completely. Not because you started an intense workout routine, but because you created the right conditions for your body to do what it was already designed to do during sleep. A few simple habits can make a surprising difference. Start your day with natural sunlight when possible. Morning light helps anchor your circadian rhythm so your internal clock stays aligned. In the evening, begin lowering your exposure to bright screens and artificial light a few hours before bed. Give your body time to recognize that night has arrived. Try to finish your last meal 3 to 4 hours before sleep, allowing insulin levels to settle before your head hits the pillow. Keep your bedroom slightly cool, somewhere around 18 to 20 degrees Celsius. And perhaps most importantly, go to bed at a consistent time so your internal rhythm stays stable. When these conditions are in place, several key hormones fall into their natural pattern. Melatonin rises at the right moment. Cortisol drops when it should. Insulin returns closer to baseline. Growth hormone can do its work. And throughout the night, your body finally has the time and the signals it needs to tap into stored fat for energy. In the end, the message is simple: you will sleep tonight. That part is unavoidable. The real question is this: will those hours work with your metabolism or quietly work against it?